Happy Monday evening, everyone. I am not going to be at school as I sent out a reminder text message earlier because my sweet little girl has strep throat. So, this is kind of a shortened version of what we would have discussed yesterday in class. Hopefully, you've gone to Canvas, you've opened up the Unit 5 module, and you have downloaded that very first chemical bonding PowerPoint. And some of the most important vocabulary words that you're going to see today are at the top: cations, anions, and ionic bonding. And first of all, we've already talked about the word ion. We've said that an ion is anything that has a positive or a negative charge. Therefore, if an atom loses electrons, it becomes positively charged. And if an atom gains electrons, it becomes negatively charged. And now what we're going to do is kind of learn some new vocabulary terms to go along with that. The first term that you come to is a cation, which if you looked at the PowerPoint, is a positively charged ion. And go back and think about, how does something become positively charged? And we said that occurs when there are more protons than electrons. And again, that should make sense to us because we understand that protons are positively charged and electrons are negatively charged. So if you have more positive charges than negative, you would expect your overall charge to be positive. And let's go ahead and take a look at some examples of what would be considered a cation. We talked in the last unit about how all atoms in that outer shell want 8 electrons. It's called the octet rule. So if we take a look at an atom like magnesium, we understand that magnesium has 12 positive protons in its nucleus, and then in that next energy level it has 2 electrons. In the next energy level it has 8 electrons, and then in the very last energy level it has 2 electrons, again going for a total of 12, which is what a neutral atom of magnesium has. Now we look at that outer energy level and we see that it has 2 electrons. You have to remember that all atoms want 8 there. So what is more likely to happen? That magnesium gives those 2 electrons away, because if magnesium gives away those 2 electrons, that next level has 8 and magnesium would be satisfied. So it could either give away 2 or it could gain 6 electrons, because if it gained 6 electrons to this outer energy level, it would have 8. But think about what we just talked about. Is magnesium very attractive to other atoms? No, because it only has 2 electrons. So what's going to happen is magnesium is actually going to give away 2 electrons. And so now what we have is a magnesium atom still with 12 positive protons. It still has 2 electrons in that first energy level, and then it has 8 electrons in the next energy level. So notice here that it has 12 positive protons, and now it only has 10 negative electrons. So when we look at this and we say, what's the overall charge? The overall charge is a +2. And so we would consider this magnesium ion to be a cation because it is positive. If you look at your periodic table, you'll notice that the groups that have low numbers of valence electrons, so think about this as group 1, 2, and then of course 3 through 12 all have very low numbers of valence electrons. These are guys that are going to give away their valence electrons. And so in looking at this, we understand that our metals tend to lose electrons and become cations. And again, that is because they have low numbers of valence electrons. So metals tend to become cations. Okay, let's talk about our second vocabulary word, which you can imagine is the opposite of cation, and that is the word anion. This is a negatively charged atom, kind of like an onion makes you cry. And again, it's the opposite of a cation. So here what's going to happen is we're going to have fewer protons, so less positive charges than electrons. And these are things that we had talked about a couple weeks ago, and here they are coming back. Let's look at an example. Let's take a look at oxygen. A neutral atom of oxygen has 8 protons. So again, we're going to think about it as 8 positive charges, and let's think back to that Bohr model electron configuration. We understand that there are 2 electrons in the first energy level, and then there are 6 electrons in that second energy level. Think back to the octet rule, and what did we just say? Every outer energy level desires 8 electrons. When we see oxygen, we see that it has 6 electrons in its outer shell, which means it's close to 8, but it's not quite there just yet. And so what would be more likely to happen? Do you think that oxygen is going to give away 6 electrons? Or do you think that it is going to try to gain 2? Because if it gains 2, then it's going to have that full 8. And you would be correct in assuming that it is actually going to gain 2 electrons. It's going to steal those from someone else. And now what we see is that oxygen still has 8 positive protons. But now, instead of 8 electrons, it has 10 negatively charged electrons, which means its overall charge would be a -2. And so in looking at your periodic table and looking at the groups, think about those elements and those families who have high numbers of valence electrons. And that would be focusing in on groups 17, 18, and 19. Group 17 has, I said 17, 18, 19. Group 15, 16, and 17. Group 15 has 5 valence electrons. Group 16 has 6, and group 17 has 7. And if you also notice, most of those are nonmetals. So we can make a very general statement here and say that nonmetals tend to become anions. Of course, we understand that kind of, especially over here down where these metalloids are, some crazy things can happen, but we'll talk about those crazy things later. Okay, and so now, let's look at ionic bonding. When you have a cation, which we have said is a positively charged ion, and you have an anion, which we have said is a negatively charged ion, we understand based on just general knowledge that positives and negatives are attracted to each other, and that is exactly what is going to happen here. If you had a magnesium, which has a +2 charge that we've talked about, and you have an oxygen that has a -2 charge, what do you think is going to happen to those 2 atoms? They're going to be attracted to each other. And so then the magnesium and the oxygen form an ionic bond, which, as you looked at the PowerPoint, hopefully is the strongest, one of the strongest bonds within chemical bonding. Those 2 charges right there cancel each other out, which is why we see magnesium oxide. So the key thing to understand about ionic bonding is that it is occurring between a metal and a nonmetal, or you could also think of that as between a cation and an anion. It's when you have a positively charged atom, a negatively charged atom, and they are attracted together, and that attraction between the 2 is the ionic bond. In the next video segment, we're going to take a look at writing chemical formulas within an ionic bond.